Yeah, hello. You can doubts Nayamana. Is anyone having any doubts? Okay. If you are not speaking, you can go on mute, please. Hello. Okay. Okay. So, okay, let's start today's class. So, as part of yesterday's class, so we have discussed about features of Unix, which is multi-user, multitasking, and along with multitasking. So, even communication, along with communication. So, we have also discussed about the few more features which are programming support and automation, and even we also discussed about then portability, and I hope everyone is clear on this multi-user, multitasking, portability, hierarchical. So at one line, multi-user means multiple users can able to connect, and multitasking means multiple tasks can be performed. One is in foreground, multiple processes are in background. And portability. So since the Unix operating system is designed on C programming language, so mainly if you develop an application or program by using any programming language, that can be run on Unix or associated operating systems with or without modifications, and security, as I told that there are immense features of when it comes to security, authentications, authorization, and along with authentications, authorizations, permissions, encryption, decryptions, and even sticky bit and AC Linux. There are lots of inbuilt features that we can use it, and it is a CLI, so command line interface. So this is also one of the major feature, major feature, and we also discuss about programming support. So it is having that programming support. So any kind of programming, so we can also create a shell programs and others, and we can work on it. And networking capabilities, so mainly, so we can any network, any type of network it can support mainly. So it can do the TCP IP, and the communications are quite easy on quite easy on so quite easy on here. And at the same time, so we're also having the modular design. So and extensive documentation means, so for every command we have a documentation, and every command we have a documentation. So by using that respective, by using a utility called man command name, we can able to view the we can with help of the manual utility of a command, we can able to get what the command does, and what are the options, and examples, and clear documentation is available on available for every command. And as I told, modular design, so which means that, so it is a as I told you that we can able to create a sample simple programs, complex programs by combining multiple simple programs into common, those kind of things we can able to achieve it by using, by using this Unix. These are the major features. So I hope it's clear for everyone. So any doubts on here? Okay. Now, so you should also know about the differences between Unix and Windows. So it's not essential to learn, but if you are having a high level knowledge, but as far as my knowledge, majority of the features, the major features are available on both operating systems. As everyone knows that Windows is a GUI, graphical user interface, and Unix is a CLI, command line interface. So the basic differences are, so the user interfaces. So as we are keep on okay discussing, Unix is mainly for okay, Unix is a command line and Windows is a GUI. So it's mainly designed a user friendly GUI. So with if you are having a Windows operating system on your system, you can usually performs the operations like creating the folder, navigating okay, folders, and creating the files and deleting the files, and okay even starting the services, opening okay, installing okay, any okay, for example if you want to install okay, any application, we can directly, yesterday we have installed okay, putty in within 2 minutes only, which means that, so such kind of okay, features are more on okay, Windows. Whereas in Unix, if you want to create a command, you should use if you want to create a file, we should use a command. For every operations, we should use the command. So, but in Windows, the GUI itself is having a command feature. So once you click on that okay, icon, automatically the backend program invokes and performs the operations. That is the, so the I mean the major difference is Windows okay, provides a rich features rich features okay, to manage the computers and performs an operations. Whereas Unix, you need to be okay, you need to okay, issue respect to command to perform some operations. That is the one major difference. And okay, when it comes with okay, licensing and okay, user source code, as I told, Unix is a as I told that okay, Unix, okay, BSD, and okay, even Linux. Okay, as you know that Windows is completely developed by the okay, the Windows is it is a proprietary operating system. So even Unix is also proprietary operating system, but the either the BSD and Linux, we can freely download and we can perform the operations. But Unix and Windows, both of them are proprietary operating system, which means it is a private. So you can't. So by default, you can't get it. You need to pay the money okay, to make use of okay, operating system. So the other differences are architecture and design. So Unix is mainly okay, it follow as I told okay, as we discussed okay, earlier, it follows okay, mainly simplicity. So which means that the main philosophy of okay, Unix is okay, building small and like a single purpose program that can be combined in scripts okay, to perform complex tasks, which means that, so you always create a small programs, and okay, then in order to if you are having a work which is a complex, you divide the work into the smaller pieces and develop that piece, and if it is working well and if there are no issues, then okay, create a new program and combine both. So in order to combine the both, so we can also create a shell programs or whatever the programs. So that way we can able to achieve the complex tasks as well. But what Windows is trying to say is, so Windows is mainly a monolithic kernel, which is integrated with integrated components, which means that lot of inbuilt features are already available on Windows. So basically, it provides a wide range of application programming interfaces and services. So mainly Unix is mainly so used with so aiming for broad hardware and software compatibility. So mainly as I told okay earlier, so Unix is having okay its own market, and Windows is also having their own okay market. So Windows market where mainly for for example, if you go to corporate offices or any banks, the frontline systems, the frontline system in the sense like the frontline systems, they are all okay people, I mean even in personal usage also. So I mean 99.9% of people always install Windows as their operating system. And whereas to run a programs, to run a critical mission services, then people will go with okay, Unix operating okay, system. That is a straightforward. Then the multi-user and multitasking capabilities are initially is not having by okay, Windows, and later they have also okay, introduced. This we already discussed on okay, yesterday. And security and stability. So the stability when it comes with okay, stability, Unix okay, has more stability compared to okay, here. So as I told, okay, as we discussed earlier, Unix has a robust security model. So there's permissions, okay, everything okay, the way. So you want while connecting authentication. So authentication on Windows and Linux are both. If you are not entering the proper username and password, you can't able to log in. And okay, if I mean even user permissions are also okay same on okay Windows and Unix. We can also control the okay, permissions, and okay along with that okay authorizations, authentications, both of them. So the stability makes, so as I told you that, so Unix, okay, is I mean Unix is always CLI, right? The unnecessary programs, okay, it won't start. So unnecessarily it won't start. So it is a kind of okay stable okay service, a stable operating system until unless you call that program will not invoke, which means that so when it comes with Windows, in order to okay, in order to support those many of okay rich features on Windows, so it has to run always a lot of background processes in order to okay, serve okay, rich GUI facilities. Whereas Unix is a CLI, right? So Unix is a CLI. So you need not to okay, okay. I mean, since Unix is a CLI, whichever the okay, whenever you want to perform a specific operation, you go ahead and run that command. So unnecessarily, okay, it stops okay running okay lots of okay background processes. So whereas in okay, Windows by default it has to okay maintain a lots of background processes okay to support those many of okay features. That's why the stability on Unix is more compared to the okay Windows, compared to the okay Windows. So okay complex. So as I told you that it has a stability. So prefer to okay, it's a prefer for critical okay, systems and all. Windows is mainly as I told you that so for office purposes and okay, personal usage, and okay even universities also people are okay universities they don't use because they if they go with Linux they need not to spend money for Windows as well, right? So people are always go with okay Ubuntu. So people always go with okay Ubuntu on universities, colleges, and okay schools and all because so students can learn and okay they can okay make use of it. So even they can also save money okay eventually. So now, so software and application support. So this is also so one of the if you go with the Unix operating system flavors or Windows operating system flavor, that will be managed by the organizations itself. If you go with Sun OS, the enhancements, upgrades, and okay, any features, okay, the Sun organization only, the Sun organization employees only okay, work on that, and okay, they can okay, I mean, from them we can purchase. Even in Windows also okay, same. Whereas if you go with okay Unix or okay BSD, so they will offer you okay, they provide you the source code. If you want, we can make n number of modifications, and okay, number of modifications, and okay, we can work on that. That is the so okay one more okay difference. Okay, that is okay one more difference. So when it comes with okay software and okay, application okay support. So Windows is completely commercial. So even Unix is also completely commercial, but okay the BSD and Linux they are okay free. And networking and okay, server use. So Unix is, as I told, okay, Unix is mainly built to okay, support okay, networking, web services, okay, database management. For those purposes only, Unix is okay, mainly okay, built. So Windows is mainly built for, as I told okay, multiple times, it's mainly okay, built for okay, okay, for both home and enterprise environments. Enterprise environment in the sense like if you go to a bank, all the bank employees who are okay, having a okay, server, they might be okay, using Windows. Whereas okay, for example, if you're having a laptop, your first choice is okay, Windows only. If you go to an organization, any organization, so everyone okay, majority of them are trying to use so Windows as their operating system. Now people are okay slowly okay switching to Open Desk. There are okay something okay, there are okay some other things are people are okay moving, but the first that is the first choice when it comes with so okay, when it comes with okay usage and all, and cost and licensing that we already know it. So okay that we already know about cost and licensing. Don't connect okay, after 15 minutes and tomorrow onwards okay, I don't okay, submit after 9:05 it's final. So then flexibility. So the flexibility and customization. So okay, as I told you, that Unix is a highly customized, and okay, Windows is also okay, offers limited customization. So okay, I mean you can change the theme settings, but so when it comes with customization, so Unix, okay, if you are having Unix operating system, we can make a lot of customization. So okay, I mean they will provide the operating system. They will provide. they will just install operating system on our system. Later, okay, if you want, we can also make a lots of modifications. Lots of modifications on top of source code, and so top of source code. Whereas in Windows, it is very less, but few features we can able to like time zones, and even themes, and even screens. There are screen, home screen, those kind of things we can able to change it. Those are the major differences between Windows and Unix. Whereas people may, you may get an interview, whenever you, if you're appearing an interview, so people will definitely ask differences between Unix and Windows, or Linux and Unix, BSD and Unix, vice versa. So you need to remember always. So always you not remember this much. So as I said yesterday, always remember. So these 5 points. These 5 points. So in between, we'll be having a Windows 1960, 70, 80, 90. So Origin Bell Labs. This is the UC, University of California, and Microsoft Linus Torvalds. So original Unix, and just remember those 4 to 5 features. If you're having more interest, we can also learn. We can also use the chat GPT. There are many features available. We can search the differences, and we can remember it. It's not a, but my intention is I just want to provide at a high level information. So at least like what is what. So to get some insights about topics. So any doubts on here? So this is what we have discussed on yesterday, and we are continuing today. Now today what we do is we will try to learn about history of Unix. So after this history of the Unix file system, so after the file system, how to install the Unix. These are the theoretical concepts. I mean, two theoretical concepts. One is architecture, and along with architecture and file system. Then later, tomorrow, I will show you how to install Linux on your Windows operating system, and what are the prerequisites which are needed, and how to enable the network, how to connect from putty, so how to do the practice, all those things we'll do it on tomorrow. But today we'll try to discuss about the architecture. So the Unix architecture, so the Unix architecture mainly contains mainly contains 4 layers. Mainly contains the 4 to 5 layers. The topmost layer is, so let's open with MS Paint. So Unix architecture is basically contains the 5 layers. So the very first layer is hardware. The very first layer is hardware, and on top of hardware, so we'll be having a kernel. So we'll be having a, so we will be having a kernel. So we will be having a kernel, KERNAL, kernel. On top of this, we are having one more layer called shell. One more layer called shell. Okay. On top of it, so we're also having basically four only people will say. So here, tools and applications. Tools and tools and applications. On top of it, we are having a users. On top of it, we are having a users. On top of it, we are having a users. On top of it, we are having a users. These are the 5 layers of these are the 5 layers of Windows operating system. So as you know that, so from the top, user, tool, shell, kernel, hardware. So in the bottom, in the reverse order. So first we'll try to learn about hardware. First we'll try to learn about the hardware. So what hardware does. So mainly as you know that hardware. So this is the fundamental layer of a physical components of the computer system. So which means that all the physical devices information. So basically hardware layer means, so your server, either your server or your computer. So where which contains the, so where which contains the physical components. What are the physical components in a laptop? In a server, CPU is a physical, memory is a physical, and okay, hard disk, and okay, along with okay, hard disk, okay, yeah, even keyboard and okay, fan and okay, motherboard, all these are the physical components, all these are the physical components, all those physical components maintained by the hardware layer. So there will be a hardware layer and okay, there will be a hardware layer. So this is the fundamental layer, contains the physical components of computer systems such as CPU, memory, IO devices. It provides the essential resources that operating system okay manages, which means that, so okay, I mean okay, which means that, yeah, okay, if a human body contains okay lots of okay organs, so that will be managed by a particular component. For example, okay, you are having so if you take a okay mind, okay, the I mean, if you are going to perform any operation, you want to okay do a okay task, then okay, who will decide it? Your mind has to okay decide, and okay, your mind will provide the instructions. So similarly, so okay, in okay, when it comes with okay, when it comes with okay, operating system, so the hardware. So the hardware is a so main component. So hardware is a main first layer of component where which will contains the physical components, where which will contains the so physical components of okay system. So nothing much to okay discuss. So okay, nothing much to okay discuss. Now the next one is a kernel. So once we installed okay Unix operating system, so once you installed okay Unix operating system, so as I told you that, so okay, okay, as we know that Unix is an operating system to perform okay to perform some operations on okay any server or computer. We are going to okay install okay we are going to okay install okay Unix, right? So in Unix, the okay in Unix, okay, kernel is a okay a kernel is a heart of a Unix operating system. Okay, heart of Unix operating okay system. What do you mean by heart of Unix operating system? So I can say that it is a actual core of the Unix operating system. Actual core of okay Unix operating okay system. So what it does means, so we do have a okay, software services and okay, hardware components. So this kernel acts as a mediator. What it does means, whatever the components are available on okay, okay, hardware layer, so this is the component will directly work with okay, hardware layer and performs an operations, which means that, so a kernel okay, I mean it is a kernel is the core, or okay, kernel is a so a kernel is the core of Unix operating system, or okay, heart of okay, or heart of okay Unix okay, or heart of so Unix operating okay system. So what it does, it acts as mainly a so mediator between the hardware and okay, software. So majorly, as I said that, so once we install the Unix operating system, I told you that okay, not only for okay, communicate, not only act as a mediator between the user and computer, it also do the okay, it also okay, performs the it also perform okay, few more important concepts, right? Like okay, process management, okay, memory management, file system management, device, system calls, everything will be managed by the kernels. Everything will be managed by the so kernel. So kernel is okay, a kernel is a hub of Unix operating system. Some people will also call it as heart of Unix operating system. So okay, without of kernel, you can't perform any operations. Okay, you can't perform any operations on Unix or Unix or associated okay, Unix operating okay systems. So primarily what it does, so in as part of hardware layer, we are having a cores and memory. So the management of okay core management and memory management, and okay with okay these two. So with the help of okay these two, only we can able to run any programs on okay system. So okay, I mean what it does means, so whenever you are trying to okay run, if you are performing an operation, so that operation, so how much resources are needed, and resource allocation, deallocation, and okay, those kind of activities also performed by the kernel, and okay, memory management and file system management. So file system management in the sense like, if you're having a okay 1 TB of hard disk, so okay, how much is as of now allocated, how much is free, how much is okay, how much, I mean, in future, whenever you are trying to access a file, so what are all the physical locations of this file? So providing those details, all those kind of details will be managed by the kernel and devices also. So okay, okay, hardware and okay, software okay, applications. and even system calls. So I mean, for example, whenever the user is performing, so all the system calls also managed by the kernel. So kernel is a so core component. So even I mean generally even on kernel, if you are having a good I mean, if you are good at C programming language, we can also work at kernel as well, because the entire programs is designed on C, right? So entire programs are designed on C. So if you are having good knowledge at C, we can also make the modification. We can also control the kernel programs as well. Now we're also having shell. So this shell is very important. So because so as you know that so in 1960s 1962 that during that time the Unix operating system is introduced. So let's take an example of the same. So you were having a computer. So you were having a computer. So let's assume that you were having a computer. So you were having a computer. So you were having a computer. So in the computer you have installed Unix operating system. So the kernel is installed. Everything is managed. Then later we are having a users, right? So if users wants to perform any operations, assume that user is connected by using putty. Putty is a tool. So user and in between is using a putty, or assume that so it doesn't have any I mean assume that so for example you have installed Unix operating system on your system, and now user is connected now. So if you want to work with kernel, so kernel is mainly built on so kernel programming language is different. So kernel programming language is different, and even hardware. So mainly what is the intent of kernel? To mainly manage the hardware components, and the to make you, I mean, in order to perform any task. So then the kernel the objective of kernel is completely different. Now so there is a user. Now user wants to create a file, or now user wants to perform a simple activity called so creating a file. So in order to create a file, so before in order to create the file before shell, it was very difficult. So you need to create one more program, and you should know the language of kernel, how the kernel will act. Accordingly you need to give the instructions. So after invention of Unix operating system, so to perform the operations I mean to perform a friendly operations on Unix operating system, initially it was very difficult. Very difficult. So now I mean what the inventors of Ken Thompson and Dennis Rich, what they have done is, hey, we have developed here one operating system. So initially with one programming language, and later by using C programming language. But so in order to perform the operations on it, in order to perform the operations on it, it becomes it becomes difficult. So they have identified this bottle. They have identified this problem, and what they have done is they have created they have created one more programs. They have created one more program, and they named that program as a shell. They named their program as a shell. What is a shell means? A shell is a command line interpreter. A shell is a command interpreter. So what they have done is, so I mean initially they are trying to do the operations with kernel on their programming on their I mean kernel, the way how kernel understands. Accordingly they used to give the instructions, and they used to perform the operations on it. Now whatever the operations the way how they are doing it, they have created a one they have introduced one mediator. They have introduced they have created one more program. So as part of that program, as part of that program, so the main intent of this program is, so whatever the instructions are giving by the user, those instructions convert it whatever the instructions, I mean commands, whatever the commands or instructions are giving by the user. So first shell will take it. Shell accepts all those commands. Once shell accepts all those commands, it converts to the understandable language of kernel. So it will convert into the understandable language of kernel, and it will give to the kernel. So which means that, so kernel, the way how kernel can understand, similarly it converts and it gives the instructions, your instructions to the kernel. Then after that, so kernel performs the operations, and it will give the output to the shell only. It will give the output to the shell. Then shell will convert the output of kernel to the understandable format of user, and it will return. So which means that, so okay, what they have done is, so as part of a shell, so a shell is another program which they have introduced to make the user operations, okay, more effectively and more friendly. So more effectively and more friendly, which means that they have introduced, okay, one mediator, or they have introduced, okay, one layer, so where users can easily give the instructions not only for the users, so it will also, okay, reduce the burden to the kernel. So it will convert everything into the kernel understandable language, and okay, they can understandable language, and they will try to perform the operation. That's why a shell is a command line, okay, interpreter. A shell is a command line interpreter. It interprets the commands. It interprets the commands or operations which are are the operations. What is the main functionality of kernel, sorry, shell? So mainly command interpretations. So translating user entered command into the actions performed by the kernel, and like a scripting and user interface. The way whatever I discuss, it's a mediator between user and, okay, user and kernel. User and, okay, kernel. User and, okay, kernel. So even the shells are also, okay, even, okay, there is a lots of, okay, changes on shells also. So initially what happened was, the initial shell, okay, the initial shell, okay, I mean after, okay, 1960, or okay, during that time, the Ken Thompson only developed a shell, okay, he named it as a, okay, SH. He named it as a, okay, SH. SH means, okay, shell. Then later, so okay, with very limited features, and okay, with very limited functionality. Then there is a user called, okay, bar. The user, okay, bar, BOURNE, born. What he has done is, he has taken the source code of, okay, this shell. Okay, he took it from Ken Thompson. Okay, he made, okay, more modifications. He added, okay, more modifications, and okay, more features, and okay, he released it again. Okay, I mean he didn't change the name, and okay, he named it as SH only. He named it as, okay, SH only. Then after that, the user Karn, KORN, Karn, at AT&T, okay, at AT&T Bell Laboratories. So again, so if you are installing the Unix operating system, by default the shell will come. Shell also install. We can perform the operation. But the user Karn identifies, okay, some flaws and some limit. Okay, I mean with his intelligence, he created a one more shell. So with more features, and okay, with more features and more functional, okay, with more, okay, functionalities. And okay, the problem was, and okay, he named that, okay, shell name as KSH. So initially whatever, so okay, whatever has developed by the, okay, Korn, okay, whatever the Ken Thompson and, okay, Ken Thompson and, okay, Born has developed, they named, okay, they have named their program name as, okay, just SH, okay, shell. Whereas Korn also developed by using, okay, his own methods, and okay, he named it as a KSH, Korn shell. So then after some years, again the user bar. So okay, again he reinvented, and okay, he spent some more time on, okay, his shell, whatever he developed, and he came up with, okay, more features and more utilities, and which whatever the bugs are having on shell, okay, he has fixed it. And okay, he also, okay, introduced lots of features, and okay, he named that shell name as BASH, born again shell. So born again, okay, shell. So again, this guy has started giving freely. So later, so even Khan shell also, okay, we are getting it as a, okay, free only. We are getting it as, okay, free only. So okay, initially couple of years, if you want to purchase a Khan shell, if you want to make use of Khan shell, you need to pay money. Okay, during some, okay, years. Then once this guy Born has introduced, delivered a new shell, he named as BASH, Born Again Shell. He started giving freely. So by default, so since it is having a rich features, even the AT&T, this Karn also started giving freely. So that's why. So we are also having a K shell. So there are different types of shells in Unix. One is SH and BASH and KSSH, CSH, SH means shell, and TCSH, TCSH. Even we're also having Z. There are different types of shells. So first is SH is bond shell. So this is a just shell. This is a bond shell. We can also call it as Ken Thompson shell also. Now we're also having a bash born again shell, which is developed by purely by the user called bar. Then corn shell. The C shell is mainly for the to run a C programs in Unix. Assume that you have developed C programs. So you have written a you have developed an application by using completely C programming language. If you want to run those C programs, so you have to make use of this C shell. Now we're also having a TCSH. TCSH means 10 times then faster than far faster than C shell. So which is having a more features of compared to C shell. So these are the different types of shells available on Unix. Different shells are types of shells available on Unix. So according to your requirements, according to your use cases, you can make use of any of these shell, any of these shell. So when it comes with shells, as I told, so a shell is a program. So that interprets user commands and execute programs. Whatever it acts as a mediator between the user and kernel. So as I told, so 1970s, so Thomson shell, and next and then Bond shell. So that's what they name it as 1970 1971 low. So the Ken Thompson has introduced a shell. That is SH. And 1979 Bond shell. And 1980s she shell. So this developed by a user called Bill Joy at University of California. So mainly used for user friendly. So command history, aliases, all these are available. Then 1980s Corn shell, KSH. So developed by the David Corn at Bell Labs, AT&T, Bell Laboratories. Then 1989 again Born Again shell. So developed for the by Brain Fox or something. So Bash is a default shell on many Linux systems. And other modular shells are ZSH, highly customizable, great features for interacting and scripting, popular among power users. Fish, friendly interactive shell, and dash, lightweight POSIX. So these are the different types of shells which are available on market. So which are available on Unix operating system. So according to our requirements, we can make use of shells. Even every shell, between every shell, we are having a differences. So if you go with C shell, it's mainly to it mainly to run to invoke C programs. Whereas with SH and KSH, we can invoke any programs, Python programs, or if you develop a program by using any programming language, that can be invoked by using these shells. And even if you go with Conn shell is still lightweight. It doesn't support the navigation keys, whereas Bond shell supports the navigation keys and even shortcuts. For example, Control R means search and Control D. So some kind of shortcuts also supports by the Bond shell. That's why we're calling as a GNU features. Whereas the GNU features are not available on Conn shell. And even declaring the variables and making use of variables is also differences between having a different on each shells. So even performance wise, Okay, I mean, even the use cases are completely different, okay, among all these shells, among all, okay, these shells. So that's why, okay, I mean, basically, so born is a shell which is a default, which is having almost all features, okay, whatever, okay, user, okay, wants it, whatever, okay, user, so, okay, required it, whatever user, okay, required. That's why, so majority of operating system, BASH is a default shell. And one more thing is, a user has a privileges. So a user has a privileges to change the shell. Okay, to change the shell. So assume that. So you are okay. You want to, okay, change. Okay, currently you are in bourne shell. You want to change it to conch shell. You can change it. From conch shell you want to come back. You can come back. Or from conch shell you want to go to, okay, again BASH. We can go. From that shell you want to go to the C shell. We can go that. Which means that the interconnectivity. So from one shell we can easily switch from one shell to, okay, another shell. So the okay, one shell to another shell, it is simple and straightforward. Just we need to, just we need to type the command. So once you type the command, automatically it will switch from one shell to another shell. That is the, so okay, that is the, okay, easiest thing on, okay, here. So as I told that the key features are, so 1971, the Ken Thompson, and okay, creator is Ken Thompson. Very basic scripting, first Unix shell. 79, structured programming, okay, features. C shell. So okay, history aliases job controls that will be supported. Con shell enhancing scripting and interactivity, and bash shell mainly. So okay, combines features for all major, okay, layer, okay, shells. Those are the things. So which means that, so as part of, okay, Unix architecture, you must have to remember what kernel does, what shell does, what is a shell, different types of shells, and okay, what is the kernel. So these are the these are the these are the basic things you need to remember when you are going to, okay, learn, okay, Unix operating system. So architecture, okay, wise, and okay, along with that, so okay, the next layer of this one is utilities and, okay, application. What do you mean by utilities and, okay, application? So, okay, as I told you that, so okay, if you want to, okay, I mean, so okay, this layer contains a collection of utility programs and applications that performs a specific task. Like if you want to, okay, the commands and everything will be available under, okay, this. So utilities. So the utilities part, okay, I mean, as I told you that Unix is having lots of commands, right? So lots of commands and all that will be, so okay, all that will be, okay, available under, so all that will be, okay, available under so okay, available under okay, available under okay, this, okay, utility space. And so all the predefined, okay, shell programs, okay, all these, okay, shell programs are available under these utility sections. And we're also having a application. Utilities means programs like okay, grab. So all the predefined programs under available in utilities. The applications are mainly, so okay, developed by the various purposes. For example, editors, compilers, whatever. If you are going to, okay, install, so if you are installing, okay, any new applications that will run on, okay, this layer, that will run on, okay, for example, assume that you are, okay, you have developed a new program, and okay, you name it as, okay, online banking system, and okay, if you are, okay, installing it on, okay, Unix operating system, that will come and, okay, sit into this, okay, fourth layer at application layer. It will be okay, it will be available. Then finally we are having a users. The users are, okay, mainly, so okay, at the topmost, okay, layer, so to interact with the system. So how do we connect the users? The users can connect to the, okay, Unix operating system directly. So okay, directly, for example, okay, directly means, so okay, once we are having a Unix shell, so what we can do is, okay, if you install RHCL or okay, any operating system, right click, okay, then okay, shell, or okay, just command prompt, directly we can able to connect and we can perform. Whereas if you want to connect from, okay, okay, from, okay, if you want to connect, okay, remotely, then okay, we can, okay, use okay, we can, if you want to connect remotely, so okay, we can, okay, use this, okay, putty, mputty, remote mg, all those things, okay, we require to connect it, we require to connect it. These are the, so major things, okay, which are okay, as part of Unix, okay, architecture. Let me show you. Okay, the okay even on okay images also it will be easy. The same. Okay, here also the okay, same thing. So as I told, so it will be okay. We'll be having so hardware, so kernel, shell, application okay, programs or utilities. Then top layer is okay users. The top layer is okay users. And okay similarly, so okay these are the okay, I mean, you may get a question if you are okay if you are going to attend an interview or somewhere, definitely okay you will get okay this question. So what is a okay shell? What is a kernel? And what are the components available on Unix architecture? So any doubts on okay here? I think okay you guys can speak. So clear? Are any doubts? I think you guys can speak, right? Okay. Or can you also chat if you're having any doubts? I think chat facility is also enabled. If you're having any doubts, you can ask your question. No? Okay. So now today, the further concepts on okay, Unix is so okay, files okay, okay then so file system okay how the file system so looks like in okay, Unix the how the file system so okay looks like okay in Unix. So as I told, okay, one of the feature on okay, Unix is Unix maintains the hierarchical okay, file systems. Unix maintains the so okay, hierarchical okay, file system. So Unix maintains the hierarchical okay, file system. So even though if it okay, if you I mean if you are okay, if you observe the tree will looks like first it will be having a okay root, okay then okay, main branches, okay then okay sub branches, then eventually we are having a leaves also, right? So similarly, the Unix operating system okay, and Unix or associated Unix operating system the okay the file system of okay it maintains the hierarchy file system. It maintains hierarchy okay file systems. So it maintains the hierarchy okay file system. The file system okay in Unix the file system is okay starts with okay root. So the starts with the okay root. And okay what are the main okay advantages of okay file system? So if we are okay having a if we are okay having a proper file system, so which okay the main intent of the okay, file system is to it provide a okay, structuring and okay, efficient method okay, for okay, storage retrieval and okay, management, which means that so if you are having the files okay if you are having a 100 TB of okay, 1 TB of a hard disk, so okay I mean if you are installing the Unix, so okay how to maintain the files, okay how to segregate the system related files and okay user related okay files, and okay okay then even management and okay retrieval okay storage, everything will be maintained okay everything will be maintained effectively, everything will be maintained okay effectively. So if you take okay any government office or okay if you take okay generally our Indian government, so we do have a so okay okay I mean if you take that, so we do have a central government and state government. So again if you take that okay okay the state governments okay first will be the so okay then CM, then okay ministers, then collectors, okay then okay subsequently one by one. Why are you okay why are you segregating okay this much okay this many okay positions? It will be easy okay easy to maintain, it will be easy to maintain, and also to okay also to resolve the okay, issues, to also resolve the so issues, and even for development everything will be okay easy, everything will be okay easy. So similarly the Unix file system also. So if you are having okay, I mean, okay, once you install the Unix on your system, so it will okay maintain the okay, it will create the first file system as okay root. So it okay, it creates the first file system as okay root, which will okay, it denotes as forward slash, it denotes as okay forward slash, which means that the file system of a Unix, so okay, will starts with okay, will starts with okay root. Okay, the root will be forward slash. Forward slash means a forward slash okay without okay anything on Unix. If you just okay use the forward slash without of anything, which means okay we are switching into the okay root, which will be the so starting of okay file system. So under this okay file system, so okay we'll be having a okay we'll be having a okay main branches. We'll be having some okay main branches. What are the main branches? We're having okay bin, and we're also having a okay etc, and we're also having a okay where, and okay temp. So then okay we'll be also having a okay us okay user, and okay we're also having a so okay along with okay user, okay we're also okay having okay kernel, and along with okay kernel, so okay we'll be also okay having okay apps. So okay apps. So okay then these are the so different okay file systems will be available okay under this. So under the okay, and along with that we're also okay having okay okay home also. So home is also another okay file system. So another okay file system, okay another yeah, okay file system. So these are the so different okay file systems which available on okay Unix. It starts with okay root. So roots denoted by the okay forward slash, and we'll be having a okay, bin. So all the okay bin okay, the bin file system contains the name itself binary. So binary executable files, which means that all commands, so all predefined programs contains under okay bin. So contains under the location called okay bin. So the programs which are available on bin can be used by so okay can be used by everyone. So can be accessed by everyone okay who has access to the okay system, so who log into the okay system. Then we're also having a okay etc. So etc means, before going to okay understand about etc, so what we have done is, so what Unix has done is, Unix is having two types, I mean the Unix users have segregated as so administrator, so okay administrator, then okay normal users, administrator and so normal users, which means that when you are installing Unix operating system, so you will also come to know as part of installation, by default it creates a root okay, by default it creates a user called okay root, root. So that user, the okay he is that okay he is the okay he is having a super privileges. Whatever he wants he can do with okay, if you know the password of okay that account, so that account you can do whatever you want. But later, so once that okay, but so we can't provide root privileges for everyone, right? If it is a multi-user capability, so if you are creating a okay, if you are installing a Unix operating system okay for okay in a specific college, so then why do we okay provide root access with for everyone? It's again a problem. It's again a okay problem. What we do is we create the users, okay we create the okay, users. After we create the users, we provide okay, certain privileges, we provide okay, certain okay, privileges. So what happens okay here is, so if whatever the files, whatever the folders which are available on okay bin, that can be accessed by everyone okay, who is okay who has access, that can be accessed by everyone. Whereas etc, okay etc means executable okay directory, which is also contains the binary executable files and important okay system related okay folders, which will be managed by okay administrator. So okay, mainly okay etc also contains the executable files, but it contains the administrative stuff. So okay, I mean, so that can be accessed by so only administrators okay, who is having root access, okay who got root access. So even we can also okay we can also okay delegate okay root privileges I mean, we can also impersonate, okay, root, okay, delegate. We can say that delegate, okay, some of the root privileges to, okay, specific users. So even they can also access to this, okay, folders, okay, which are under, okay, etc. Then where, so as part of where, so okay, which will be contains that, okay, system related, okay, log file. Even in Windows also will be having okay, Windows event logs and all, right? So even on, okay, Unix, so the where file system, it is the name itself is variable files like logs, mail, temporary files, all will be under, okay, where. And okay, we're also having, okay, temp. So temporary files is mainly for, so for example, whenever you are creating a, I mean, if there is a program, the program is, okay, creating some temporary files. So if you want to, okay, store those temporary files, okay, until the program executes and you want to remove that, so for that purpose, okay, we go with, so temporary file system that may be deleted upon the system reboot. And okay, dev, so the one more is, okay, dev. So dev will contains the divisible files. So whatever the devices, okay, we are going to keep all those, okay, okay, all those, okay, files, okay, those, okay, devices information, like, so how many okay, the processors information, disks information, okay, cores information, all this will be, so all the physical devices information will be available under forward slash, okay, forward slash, okay, dev, forward slash, okay, dev means, okay, devices. So dev means, okay, devices. Then we're also having a proc. So it is a virtual file system providing the process and, okay, I mean, for example, so the course information, memory, those informations will be available under, so proc. And we're also having a, okay, home, the user's home directory. So whatever the users we are going to create in future, whatever the users we are going to create, so they are privileges to, so by default, okay, will provide, okay, okay, one folder, the user has to work on that folder only. Then, okay, etc, okay, bin, and we're also having the mnt media. So these are all the, so different types of, okay, mount points which are, okay, available on, okay, systems, which are available on, okay, system, okay, which are available on Unix operating, okay, system. So mainly ఎందుకురా అంటే the main, okay, intent of, okay, okay, the main, okay, intent of, so this Unix operating system is, the file system is to organize and manage the, okay, the, to manage the space and, okay, the space which is available in, okay, system, so available in, okay, system. So even, okay, I mean, generally also, okay, what we do, we delegate the activities, right? So if you're working in an organization, so the organization contains the CEO, then, okay, then inside the CEO, okay, then, okay, okay, directors, okay, then, okay, managing directors, then it will be having, okay, vice presidents, it will also having team leaders, team members, eventually the team members. So we maintain some hierarchy. Why do you maintain? Okay, very simple. Not only for, okay, here we I mean, if you go to, okay, if you consider as a school, okay, if you consider as a school, okay, school, okay, how the, okay, okay, how the hierarchy looks like in school. School starts with principal. So inside the principal, there will be a, okay, okay, inside the principals, okay, there will be, okay, HODs, head of departments. Okay, for, okay, inside the HODs, for every each class, okay, will be having a, say, SPL, okay, school P, okay, the, okay, that, leader. Then, okay, teachers head. So okay, why are we going to segregate these roles? So if we are, okay, with help of these roles, we can easily manage the work. We can easily assign the respective roles to them. So okay, we can, okay, achieve, okay, we can achieve, okay, our goals. That is the main, okay, intent of, okay, segregating the roles. Here also we are segregating the file system. Okay, these are the basic file system which, okay, Unix, okay, maintains, which, okay, which Unix, okay, maintains.